Student, today we will learn the chapter Exponential Series. Today we will learn this chapter Exponential Series. As you already learned the binomial theorem in the previous lecture, after that you can learn this chapter Exponential Series. Okay, we will use the binomial theorem in this chapter. Now, first I will tell you 1 plus 1 upon n to the power n. Here we take the limit of n tends towards infinite. N tends towards infinite. And this is denoted by a small letter e. Here e is known as exponential. The limit of this, what we found, that is the exponential. Okay. Now you can see here 1 upon n is less than 1. Therefore, we can use the binomial theorem for any index here. Right? So, what we find here, 1 plus n x, where x is 1 upon n. Now you know the binomial theorem. Plus n minus 1 upon factorial to x square. Here x is 1 upon n square. Plus n minus 1, n minus 2 upon factorial 3, 1 upon n cube. This series is up to infinite, as you know, in the binomial theorem. Right? So student, now we are taking for limit this. First we cancel out this n. This n square can be cancelled out by taking n here common. So we can write here 1 plus n into n, 1 minus 1 upon n upon factorial to 1 upon n square. This n square will be cancelled from here. Okay, and similarly in this we take the common n, 1 minus 1 upon n, here common 1 minus 2 upon n upon factorial 3, 1 upon n cube plus dash dash dash, and you can see here is n cube is also common, and we have to take the limit n tends towards infinity. So now we put the value of n infinity. We find 1 upon n is 0. Okay. So n tends towards infinity, hence 1 upon n equal to 0. Right? 1 upon infinity, we can say it is equal to 0. So now we put this value here. What we get? 1 plus 1 minus 0 upon factorial 2 plus, you can see again here, 1 minus 0, 1 minus 2 upon 2 into 1 upon n means 0 upon factorial 3. Okay, so we can write 1 minus 0, 1 minus 2 into 0 upon factorial 3 plus dash dash dash. So we find here 1 plus 1 upon factorial 2, this 1 minus 0 upon factorial 3, and so on. So we can get the value of e that can be explained by this, that is 1 plus 1 upon root 2, 1 upon root 3, 1 upon root 4, and so on. Okay, so this is the exponential. The meaning of this is exponential. The value of this is this one. And you can see if you solve this is 1 plus 1, 2, and this is 0.5, and this is, if you solve, is 1 upon factorial 3, 1 divided by 6. It means 3 you have to divide it by factorial 2, 0.5 upon 3. Okay, and this way you can find the value of this, then 0.5 divided by 3 divided by 4, and this way you can solve very easily. So we can get the value of this way, 2 plus 0.5 plus and the value of this you can divide by 3, you can 0.66 0.1666 dash dash dash, and plus similarly you will get here 0.041666, and this way if you want to take in more decimal value you can find up to 9 place. So adding this we get the value of E. E is 2.718277. Okay, so more, if you taking the more terms you will find the changing of the value of here. So you have to learn 2.718 up to 3 or 4 decimal, so you can use it in another questions. Okay students, this is a very important value of E. This is the very important value of E, and this value of E we will use in log. To finding the any calculation we will use the log, and where we will use this value of E. Okay student, so now I would like to tell you, prove that 2 less than E less than 3. How will you prove it? Okay, so student, we can write that E equal to 1 plus 1 plus 1 upon factorial 2 plus 1 upon factorial 3 1 upon factorial 4 dash dash dash. Let this value is 2 plus let this all value is P. So we can say E 2 is less than E. Okay, since E is 2 plus P, so 2 is less than 2 plus P, means 2 is less than E. Okay, this is the condition 1. Now if we can see here the relation between 1 upon 2 and 1 upon factorial 2, that is are equal. Okay, so now we can see 1 upon 2 square, that is 4, is and here we can write factorial 3. So this 1 upon factorial 3 is a 6, value of 6 here, 1 upon 6, here it is 1 upon 4, it is less, so this is greater. Okay, now 1 upon 2 cube is greater than, similarly 1 upon 2 4, and similarly 1 upon 2 4 power 4 is greater than 1 upon factorial 5. Okay student, and the value of 5 is greater than this, so this value is less, so total this value is greater than this. It is reciprocal here. If it will be greater, it will be less, then this will be greater than this. And similarly up to infinite, if we add it, so we got it here, a GP up to infinite, the sum of GP up to infinite using the formula a upon 1 minus r, or r minus 1 minus r. If r is less than 1, it is up to infinite in GP. If you have read it GP, then you can understand. And here we are finding here a is 1 by 2 and a ratio is 1 by 2, so we can write here 1 upon 2 upon 1 minus 1 upon 2 is greater than, and this sum is, we can write the value of p. Okay student, so after solving this, what we get? 1 upon 2 upon 1 minus 1 upon 2, that is 1 by 2, is greater than p, 1 greater than p. So since 2 less than e, okay student, but and since e equal to 2 plus p, but p is less than 1, since p is less than 1, hence e is less than 3. So we can write using this and this, we can say 2 less than e less than e less than 3. So student, this phenomena, this formula is very useful, and the value of e I have already explained. Okay student. Now I want to say the next topic, that e to the power x, and we can write this 1 plus 1 upon n to the power nx. Okay student, so similarly, if we writing this using binomial theorem, we can say 1 plus nx, n and x is 1 upon n, plus n minus 1 upon factorial 2 x square. Okay student, so this way you can use. So after cancelling this n, what we get here, 1 plus x plus, and taking the n square, x minus 1 upon n upon factorial 2 1 upon n square, cancel out this, and same way other term. Now putting the value of n, we will get 1 plus x minus 0 upon factorial 2, and same way we will get 1 plus x square upon factorial 2 plus x cube upon factorial 3, and so on. So what we got the series? We got the series that e to the power x is 1 plus x square upon factorial 2 plus x cube upon factorial 3, x4 upon factorial 4 plus dash dash dash. Now you can also write here 1 upon factorial 0 plus x upon factorial 1 plus x square upon factorial 2. So to solving the questions carefully, we want to write here if factorial 0 and factorial 1, then there is no problem, you can write it. Okay student, and what is the meaning of the factorial, you understand in the better in chapter permutations. So this series you have to learn carefully. Okay student, now I will like to tell you that if we say here e to the power minus x, so you can put here x as minus x, so you can see where is the power of x is even here, and where the power of x is odd. So you can see if power is odd, it will be negative. If power is even, the sign will be positive. Okay, alternate sign, 1 minus x, plus minus plus, plus minus plus, and so on. So you can see here, this way you can alternate signing, you can solve this one. and let we add this. What we get here, if we want to add this, now ex plus e minus x, you can add this 1 plus x square upon factorial 2 plus x cube upon factorial 3 dash dash dash, and if you add this 1 minus x plus x square upon factorial 2 minus x cube upon factorial 3 and so on, if you want to be add this, you can see the value will be left, this will be cancelled, this will be cancelled, and what we left here, 1 plus 1 2 taking to a common 2, 1 plus x square upon factorial 2 plus x to the power 4 upon factorial 4, x to the power 6 upon factorial 6, and directly you have to learn this value. This value you have to learn it. Similarly, if we will subtract it, what we get here, then this will be cancelled and this will be double. So we can say 1 plus x square upon factorial 2 plus x cube upon factorial 3 plus x4 upon factorial 4, and we can see if we subtract it minus 1 and plus x minus x square upon factorial 2 plus x cube upon factorial 3 minus x to the power 4 upon factorial 4 and this way when you solve it, you will get twice of x, this will be cancelled, and here this is cancelled, this is cancelled, we will get x plus x cube upon factorial 3 plus x to the power 5 upon factorial 5. This formula also you have to learn directly. Okay student, now I will see more. Now if we write e to the power cx, then using this theorem we can write as x as cx plus cx square upon factorial 2 plus cx whole cube upon factorial 3 plus dash 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 and so on. Now if let c e to the power c is constant a, then taking log, how we can write the log? Okay, so we can write it log of a add base e equal to c. Okay student, so we can write here a to the power x, since e to the power c equal to a, that is 1 plus c is log ea, so we can write here x into log e base a plus x into log e base a whole square upon factorial 2 plus and so on. So this is exponential for any constant, value of a is any constant 2 3 4 5 and so on. So if you want to be if you want to use this series, you can learn that a is any constant. Okay student, are you understanding? Right, so I want to tell you some one things that very important point. If the notation of factorial is in negative, what we can write is it the value of 0? Now we have to prove it. Is this 1 upon factorial minus n is 0? Okay, so we can say here we can write 1 upon factorial n minus 1 multiplied by n and divided by n, we can write n upon factorial n. Okay, now let put n equal to 0. What we get? 1 upon factorial 0 minus 1 equal to 0 upon factorial 0, and we know the factorial 0 value is 1. So we can write this 1 upon factorial minus 1 is 0 upon 1. So we can write factorial minus 1 is 0. Okay student. Similarly, if we take 1 upon n minus 2, we can multiply this by n minus 1 and divide by n minus 1. What we get? Factorial n minus 1. So now putting n equal to 0, let put n equal to 0. Then what we get? 1 upon 0 minus 2 equal to 0 minus 1, 0 minus 1, and that is we get 1 upon factorial minus 2 equal to minus 1 into 1 upon factorial minus 1, and we already know this is 0, so we can write minus 1 into 0 equal to 0. So 1 upon factorial minus 2 is also, the value is 0. Okay. Similarly, if we take for n minus 3, and this is multiplied by n minus 2, what we get here? Now let n equal to 3, n equal to 0. So we get 1 upon 0 minus 3 equal to 0 minus 2 upon 0 minus 2. So we get minus 2 into 1 upon minus 2. Now this is 0. So we can write minus 2 into 0. So we can say 1 upon factorial minus 3 is also 0. Okay. So this way, factorial value, if n is, we can say for all n, hence for all n as positive integer, 1 upon factorial minus n is equal to 0. This is a very important point. Okay, note this formula so you can use it correctly. So now student, I want to tell you it's a few questions according to this. So do these questions. Now let the question start. To prove 1 upon e equal to 2 upon factorial 3 plus 4 upon factorial 5 plus 6 upon factorial 7 and so on. Okay, now how you can prove it? Since LHS equal to 1 upon e, we can write at e minus 1 using the exponential series. Here e to the power x, what is the value of x? Minus 1. So we can use 1 plus minus 1 plus minus 1 square upon factorial 2 plus minus 1 cube upon factorial 3 plus minus 1 to the power 4 upon factorial 4 and so on. So what we get here? 1 upon e equal to 1 minus, we can write it 1 plus this is 1 upon, and solving this we get factorial 2, and here is minus 1 upon factorial 3, and we take in bracket. Okay, similarly we will take 1 upon factorial 4 minus 1 upon factorial 5, and so on. So we can write 1 equal to 0, this bracket also. We can write 0 plus, now taking LCM factorial 3, here we get 3 minus 1 plus taking LCM factorial 5, we get 5 minus 1. How are we getting this LCM? Factorial 5 means 5 into factorial 4. So factorial 4 is cancelled, so we can write here 5 and minus 1. Now solving it, we get 1 upon 0, 2 upon factorial 3 plus 4 upon factorial 5, and similarly so on. We can find 6 upon factorial 7 plus dash dash dash, hence it is proved. Okay student, now you can see next more question. Now you can see one more question is let e square, to prove e square plus 1 upon e square minus 1, that is 1 plus 1 upon factorial 2 plus 1 upon factorial 4, 1 upon factorial 6 upon 1 plus 1 upon factorial 3, 1 upon factorial 5, 1 upon factorial 7. So let's start with LHS e square plus 1 upon e square minus 1. We can write it taking e as a common, e plus 1 upon e upon, taking e common, e minus 1 upon e. This is cancelled, so what we get? E plus e minus 1 upon e minus 1. Okay student, then we will write these two expansions, then we can get the answer. So what is the value of e? 1 plus 1 plus 1 upon factorial 2, 1 upon factorial 3, 1 upon factorial 4, and here we get 1 minus 1 plus 1 upon factorial 2 minus 1 upon factorial 3 plus 1 upon factorial 4, and so on. Similarly in dividing, we will put minus, we can write here minus, dash dash dash, here also dash dash dash. So now you can see in adding 1 plus 1 twice, this will be cancelled, this is twice, and this is cancelled. Here in minus 1 minus 1 is cancelled, but 1 plus 1 is double, and 1 by factorial 2 minus factorial 1 by factorial 2 cancel, 1 by factorial 3 will be double. Okay, so we can write in easy way, dash twice 1 plus 1 upon factorial 2, 1 upon factorial 4, 1 upon factorial 6, and so on. In division, double of 1 upon factorial 3, 1 upon factorial 5, 1 upon factorial 7, and this cancel out, so we get the right hand what we have to proved. Okay student, so what we have to prove, that we have got it here. Okay student, so I think now you have learned better. the formula and how we will use it. Are you understanding? Okay student, we will take the more questions. Let the question is find coefficient of x to the power r in the expansion of a plus bx upon e to the power x. Okay, so we can write this way, a plus bx into e to the power minus x, and we can understand this when we expansion this, we get 1 minus x plus x square upon factorial 2 minus, okay, this we alternate plus minus term because it is negative. So if we want to be find the coefficient of x to the power r, it means when we multiply this, you can see a, if multiplied by 2, then bx, then it is cube. So taking to understand this value a bx, and when we multiplied a in the coefficient of x to the power r, and b is multiplied in the coefficient of x to the power r minus 1. Okay student, so we write these two more step, minus 1 to the power r minus 1 x to the power r minus 1 upon factorial r minus 1, and minus 1 to the power r x to the power r upon factorial r, and so on. Here is minus 1 to the power 1, minus 1 to the power 2, minus 1 to the power 3, therefore it is negative. Okay, so we are writing this way. Understanding? Now we can understand coefficient of x to the power r, hence coefficient of x to the power r will be a into this and b into this. Okay. So we can find out a into minus 1 to the power r upon factorial r plus minus plus b into minus 1 to the power r minus 1 upon factorial r minus 1. Right? So now taking the common here, minus 1 to the power r, we can take the common, minus 1 to the power r minus 1. If we now we can write it this way, factorial r minus 1. Now if we write here minus, then we can add 1 minus power here, if we write here minus. Okay, and if we multiply it by r and divide by r here, but we get factorial r. So we will do one more thing, that is we can write here a into minus 1 to the power r upon factorial r, and we can write plus minus 1 and minus 1 to the power r minus 1 into minus 1. So this is minus minus positive and this is minus r, and if we multiply it by r factorial r minus 1 b, this we have do the extra. So we can write this minus here, okay, and this minus here, and this r b, and this is factorial r. Now you can see here we can take the common minus 1 to the power r upon factorial r LCM, and we can write a minus b r. Okay, now what we have to find out the coefficient x to the power r, and so this is your answer. Okay student, now we will do more questions that find sum up to infinite. 1 square plus 2 square upon factorial 2 plus 3 square upon factorial 3 plus 4 square upon factorial 4. In this type of the questions, first we find the nth term. Now you can see nth term is square of 1, 2, 3, 4. Okay, so Tn of 1, 2, 3, 4 and square, and upon here is factorial 1, factorial 2, factorial 3, factorial 4. We can write Tn of 1, 2, 3, 4 factorial, and this is AP. So what is the nth term? That is a plus n minus 1d, and here is also we can write a plus n minus 1d. In AP you know the Tn term, AP 1 plus a plus n minus 1d. Okay, if you don't know, you have to learn the chapter AP, arithmetic progression. So what we get here, 1 is cancel, n square, that is n square upon factorial n. Now how we will solve it? When we got the value of Tn, we write n square this way, so that in numerators n should be cancelled out with the help of denominator. Okay, so thinking this, we can write is n upon n, taking n common, so we can find out n. 1 n is cancelled, but 1 n is left. So when we think is what is here, n minus 1, so we use here n minus 1. Okay, but we write here n minus 1, so we write also plus 1, so that it is also equal. Now separate this, learn carefully this step. Okay, now we can write this again. We can write taking n minus 1 out, and then n minus 2 plus 1 upon factorial minus 1, so that this is cancelled. Now we can see here, now there is no n on the numerators, so now we write this way. Now T1, we can write here, putting the value of n equal to 1, we get 1 minus 2 plus 1 upon 1 minus 1. Okay, now T2, we put here 2, so we get here 2 minus 2 plus 1 upon 2 minus 1. Now T3, 1 upon 3 minus 2 plus 1 upon 3 minus 1, and so on up to infinite. So what we get here? We get here 1 upon factorial minus 1, 1 upon factorial 0. Okay, 1 upon factorial minus 1, 1 upon factorial 0, and here we get 1 upon factorial 0, 1 upon factorial 1. Here we get 1 upon factorial 1 plus 1 upon factorial 2, and so on. The negative value in factorial, I have already described it. This value, total value is 0. So now if we add these column wise, what we get? 1 upon factorial 0 means 1, plus 1 upon factorial means plus 1 upon factorial, that is e, and from here we got t. Okay, so adding column wise, we get the value of here e plus e, isn't it? Do you understand? No. So so adding column wise, we get here s equal to 0 plus 1 upon factorial 0 plus 1 upon factorial 1 and so on, plus 1 upon factorial 0 plus 1 upon factorial 1 plus 1 upon factorial 2 and so on, and that is e. Okay, so it is e. The total value is 2e. So this way we got the sum in the terms of e. Okay. Now I want to be describe you one more questions so that you can understand better way. Now find the sum up to infinite, and the series is 1 plus 1 plus 2 upon factorial 2, 1 plus 2 plus 3 upon factorial 3, plus 1 plus 2 plus 3 plus 4 upon factorial 4 and so on. And we have to find the sum of this series. So now the solution is, we will get the Tn. Now you can see sum of this 2 term in second term, sum of 3 term in the third term, sum of 4 term in the fourth term. So Tn term will be sum of 1 plus 2 plus 3 plus 4 up to n term, and upon similarly in factorial Tn of 1, 2, 3. Okay, so using the sum of formula of AP, you can find the sum of this term, and using here n, then you can find the answer. So sum of n term is that is n plus 1 upon 2, and here is we get a plus n minus 1 d. So n plus 1 upon 2 factorial n. Okay, now as I have already told, we will write this we will write this way, so that upside n should be not n minus 1, this is n cancel. Here is n plus 1, here is n minus 1, we have taken a n minus 1. So we can write here n minus 1 plus 2 upon 2 factorial n minus 1. So we can write here 1 upon 2 n minus 1 factorial n minus 2 plus 2 upon 2 factorial n minus 1. Okay, we can separate this and factorial n minus 1 here open, so that this is cancelled. So what we get, 2 upon factorial n minus 2, 1 upon factorial n minus 1. Okay, now what we get here, Tn. Now putting T1, T2, T3 column wise, what we get here. So T1 putting n equal to 1, so we get 1 upon 2, that is minus 2, and here we get also 0, putting here n equal to 1, 1 minus 1, 0. Okay, 1 minus 2 minus 2, 1 minus 2 is minus 1. Now putting 2, 1 upon 2, 0, plus 1 upon factorial 1, 3, we get factorial 1 plus 1 upon factorial 3 minus 1, 2, T4 equal to 1 upon 2 factorial 2 plus 1 upon factorial 4 minus 1, 3, and so on. So what is the sum? Adding here we get 1 by 2 taking common, this value e, okay, this is 0, so we get 1 upon 2e, plus also we can get here e, so it is equal to 3 by 2e. This is your answer. Similarly, you can use one more questions. That we have to find the sum of up to infinite, sum up to infinite 1 plus 1 plus 2 upon factorial 2 plus 1 plus 2 plus 4 upon factorial 3 plus 1 plus 2 plus 4 plus 8 upon factorial 4. Same question, but here is GP. Okay, so we can find sum of 1, 2, 4, 8 up to n term. It is GP upon here Tn of 1, 2, 3, 4. So what we get here, sum of n term in GP, that the formula we know that a r to the power n minus 1 upon r minus 1. Here r is 2. 2 by 1 2, 4 by 2 2, 8 by 4 2. Okay, so we get here a plus n minus 1 d. So what we left here? We left here 2 to the power n minus 1 upon factorial n. So you can see 2 minus 1 1. Okay, so now using this we can put the value of t1 t2 t3 and so on. We can find it tn equal to 2 to the power n upon factorial n minus 1 upon factorial n. So we get t1 equal to 1 upon factorial 1 to the power 1, t2 equal to 1 upon factorial 2 to the power 2, t3 equal to 1 upon factorial 3 dash dash dash, and adding column wise you can find out here is 1 upon factorial 2 1 upon 3, here is x. Okay, x upon factorial 1, x square upon factorial 2, x cube upon factorial 3, and here is e. Here is but 1 upon factorial 0 is less, here is 1 is less. So what we can write here? What we can write here? We can write here that is e to the, if we add here 1 plus 2 upon factorial 1, 2 square upon factorial 2 dash dash dash, we subtract the minus 1. Okay, similarly taking minus common, if we add 1 plus 1 upon factorial 0 plus 1 upon factorial 1 we can write here 1 plus factorial 0 plus 1 upon factorial 2 dash 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 and now subtract it. We can get minus this adding 1, this minus 1. Okay, so now we get this value is e to the power 2 and this is minus 1 and minus this is e and this is minus 1 and this should be in a bracket. So what we get? E square minus 1 minus e plus 1. So we got e square minus e. That is your answer. Okay, student. So student, I will require one more questions. Prove that in expansion of e to the power ex to the power x. Coefficient of x to the power r is 1 upon factorial r, 1 to the power n upon factorial 1, one to the power r plus 2 to the power r upon factorial r, factorial 2 plus 3 to the power r upon factorial 3 plus dash 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 and so on. So we want to find the coefficient of x to the power r in the coefficient of e to the power x. So we can write e to the power x using this as x. So we can write 1 plus x square upon factorial 2 plus x cube upon factorial 3 and so on. Okay, so we can write also 1 plus ex plus e to the power 2x upon factorial 2, e to the power 3x upon factorial 3 and so on. Okay, now this step we will be open again for ex, and then what we got it? We got it 1 plus 1 plus x upon factorial 1 plus x square upon factorial 2 plus x to the power r upon factorial r, and next we will got it 1 upon factorial 2 outside and 1 plus 2x upon factorial 1, 2 square x square upon factorial 2 and so on to the power r, x to the power r upon factorial r. And similarly in third step we will get 1 plus 3x upon factorial 1 plus 3 square x square upon factorial 2 plus dash 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 3 to the power r, x to the power r plus dash dash dash. So and so on and so on. Now we can check hence coefficient of x to the power r we got here, and this one 1 upon factorial r. Okay, and 1 upon factorial 2 to the power r upon factorial r, and 1 upon factorial 3 to the power upon factorial r. Taking factorial r common, we get here x to the power or 1 to the power r, and also we can write factorial 1. That here is factorial 1. So we can write here factorial r common to the power r upon factorial 2 plus 3 to the power r upon factorial 3. This r is common. Okay, so this we have proved it. Okay student, so you will do so many questions of exponential. In the next video I will talk about the logarithmic series. Okay, but in this video I am not explaining, and the next video I will talk about the logarithm series. So you have to wait for same for logarithmic series. Thank you for this video. Thank you for this watching. Thank you.